Hi friends, welcome to Data Engineering. This is Manisha and I will discuss about Big Data and Hadoop fundamental in today's session. This session is specifically for those who would like to start their career in data analytics and engineering from grassroots level. Hope you will enjoy the session. So let's move forward and look into the agenda. So in agenda, we will be discussing this list of topics. So those topics are what is data, what is big data, growth of big data application, types of big data, concept of Hadoop, high level architecture of Hadoop, Hadoop version, Hadoop components, data processing techniques in Hadoop, and some points to remember, and in last some interview questions on Hadoop. Now, before coming to big data, first we would like to know what is data exactly. So the data is the quantities on which the operations are performed by computer and it is stored and transmitted in form of electrical signal and recorded in different recording media. Now coming to big data. Big data itself is a says it's collection of data that is huge in volume and it is growing exponentially with time. It is a data with so large size and complexity that none of traditional management tool can store it or can handle it efficiently. So that's why big data, the growth of big data is enhancing day by day. So here we will explain how the big data is now moving first and how it is growing exponentially day by day. Initially, we had to work max to max gigabyte data, but nowadays due to huge amount of data volume, it is increasing day by day and from gigabyte it going to terabyte, from terabyte it is going to petabyte, from petabyte to exabyte and from exabyte to zettabyte. So in this rapid range, it exponentially it is increasing especially in IT and application server logs, web service, mobile application, sensor data, and especially in social media like WhatsApp, Facebook, Insta. Every single second, huge millions and billions of photos, videos, and images are uploaded. So in this way, the big data is now enhancing day by day in huge amount. Now coming to the big data applications. Here I would like to explain what are the areas mainly the big data are applied. There are different sectors like banking and securities, insurance, transportation, education, energies and utilities, healthcare, media and entertainment, and many more areas big data is used massively. Now coming to the types of big data. What are the big data types? Here there are three types of big data there: structured, semi-structured and unstructured. Structured data is nothing but the data which is having the fixed format and fixed schema. That is in terms of structured data. The examples of structured data is any of the table where the data is stored. So those data we can consider as a structured data. Now coming to the semi-structured data. Semi-structured data is nothing but a not the exact structured data, not the exact unstructured data, that is between structured and unstructured data. So if you see the examples of XML file, then you will see that the XML file data is not exactly the structured format, but not exactly also the unstructured format. So that's why we can consider this XML file is one of the example of semi-structured data. Now coming to unstructured data. Any data with unknown form or any unknown structure, it doesn't have any fixed format or fixed size, that is called unstructured data. In addition to this, there are multiple challenges in terms of its processing of deriving its unstructured data. So that's why the examples of unstructured data is the data source which is a combination of video, image, audio and all different things. So I can consider the example of unstructured data is the output written by Google search. If you do the Google search, after that you will find different type of image, video, audios are there. So those doesn't have neither any fixed size or any fixed format. So that's why we can consider this as one type of unstructured data. Now coming to the concept of Hadoop, how Hadoop is initialized in big data. Actually, nowadays there are enormous data is being generated with high velocity. So the traditional RDBMS system is not able to handle this huge amount of data. And also they are not capable of handling this data due to this huge density. And that's why it becomes difficult to handle those data which is growing rapidly day by day, and to process those data also with high processing speed is also one of the greatest challenge in front of us. So that's why Hadoop came into existence, which is capable of handling large data set efficiently. Now what is exactly Hadoop? Hadoop is an open source framework. One framework has been provided to big data so that the huge data can be handled in efficient manner, and it can be processed also with highest maximum speed. So in this way Hadoop came into a picture, and we consider that Hadoop is one of the platform where big data can be handled efficiently. So Hadoop big data, before initializing the Hadoop concept, I would like to say the minimum block size of Hadoop is 64 MB, and for Hadoop version 1, and for Hadoop version 2 this is 128 MB. I will discuss in detail of those block size in later, but just for the concept I mentioned this point. Now here in this picture I am showing you the high level architectural perspective of Hadoop. That means what is the overall default architecture of Hadoop framework. So if you see here in left side there are two layers are there. In Hadoop mainly there are two layers is the present, HDFS and MapReduce. So HDFS layer is mainly responsible for storage purpose, and MapReduce layer is mainly responsible for data processing purpose. And the components which are mentioned like name node, data node, and job tracker, task tracker, those are mainly responsible for storing and processing the jobs accordingly. So each and every block I will individually explain in later slides. So in the latest slide, I have given you the overall default architectural perspective of Hadoop. So basically after coming to Hadoop version 2, there are some changes came. So that's why before going to in details of the Hadoop component, I would like to say about what was in Hadoop version 1 and what are the components have been added in Hadoop version 2, so that I will discuss every component step by step in later slide. So in first Hadoop 1, that is the first version, that is a single use, that is for batch processing only. So in this Hadoop 1, there are only two components. One is HDFS, which is mainly responsible for storage purpose, and another is MapReduce. This is mainly for data processing and cluster resource management system. But for the Hadoop 2, one additional component has been added, that is Earn. So Earn is the another data processing tool which is mainly responsible for cluster resource management. If you see in slide, in Hadoop version 1, MapReduce is both responsible for cluster resource management and data processing. But in Hadoop 2, once Earn comes, then Earn is mainly responsible for cluster resource management, and data processing is mainly responsible by MapReduce. So as the work is divided into two parts in MapReduce and Earn, so the data processing becomes much more faster in Hadoop version 2. There are other processing engines are there which I will discuss in later. So this is the overall Hadoop 1 and Hadoop 2 version. Now coming to what are the Hadoop components. As in my last slide, I have mentioned that Hadoop 2 is the latest Hadoop version. So on that version, Earn is another new component which has been added. So I have added this three layer as a Hadoop component for explaining in detail for all those things. So the first one is HDFS, that is for storage layer. So in storage layer, there are two uh, storage unit is there, that is name node and data node. And MapReduce layer is mainly responsible for processing purpose. So for data processing, mainly MapReduce is responsible. Here there are two parts is there. Map phase and shuffle, short phase, reduce phase. There are three phases are there which are mainly responsible for processing the data. Now the third number is EARN, that is the management layer which is mainly does cluster management system. So now first coming to the HDFS layer, as in last slide I have mentioned, HDFS is mainly responsible for storage purpose where the components are name node and data node. So here let me tell you every detail what is the purpose of name node and data node. If you see this first image, their name node is the first thing. So first of all, I can tell you that name node is a node which is the heart of the Hadoop system, which gives the instruction to the other node which needs to be done. So a name node is mainly responsible as a master which gives the gives the instruction to everything which needs to be done. So if you see the first picture, there is HDFS client. We as a client work in Hadoop system. When you will work in any of Hadoop edge node, you will consider that you are as a HDFS client. So what happens is HDFS clients basically gives the file to name node. For example, a file is containing 1000 MB. So as I mentioned in Hadoop 2, the minimum block size is 128 MB. So first what happens, the file is divided into several blocks. It means that 1000 MB file in Hadoop version 2 will be divided into 1000 by 128. So that many number of blocks will be present, and those blocks will be processed in entire rest of the node. So first step is it is divided that file into several blocks as per the size, and then it gives the instruction to data node. So what data node does, in data node the blocks are written, and then it gives the acknowledgement signal to HDFS client that yes, it received that block. So I can proceed for processing rest of the block. So after processing the block by the first data node, what happens? It passes the work to the next data node. So next data node also does the same work. It writes the data and then it gives acknowledgement signal to the previous data node. So in such a way, in a specific cluster, if the number of data node is 5, so in 5 data node, the data is processed and it is acknowledged to the last data node, and as last it is going to HDFS client. So in this way, the blocks are stored, means blocks data are written into data node, and it gives the acknowledgement signal accordingly to HDFS client and name node then. So if you see that second picture in detail, it is mentioned more that this client gives a job assignment to the cluster, and mainly name node has master node and job tracker. So what happens? Name node gives an instruction to slave node. It means that name node belongs to master and data node belongs to slave, because data node is instructed by name node. That's why name node is considered as a master and data node is considered as a slave. So if you see here, name node gives the data assignment to data node and gives a task assignment to task node, task tracker. So mainly data node stores the data and task tracker process that information. So that is the individual task of data node and task tracker. So I think you are clear for this point that what name node exactly does and slave data node and task tracker exactly does. Mainly task tracker's instruction is given by job tracker. So job tracker gives the instruction to task tracker that this needs to be processed. So overall we can say name node gives the instruction for storage purpose to data node and job tracker gives the information of processing thing to task tracker. So in such a way the data are processed and data are stored into different blocks. So this is the first stage of HDFS layer. Now second steps I have mentioned, that is the mapreduce layer. So mapreduce layer is mainly responsible for processing of data. Now coming that how the data is processed. So here I have given one example so that it would be easier for you to understand clearly what exactly is happening while processing of data. Last slide I have mentioned how the data is stored. But here I am explaining how the data is processed. So in input, I consider there are different words are there. So if you see, the dear word is presented 2 times. Beer is also presented 2 times. And car is presented 3 times. River is 2 times. So in output, what we should get, that deer would be 2, car would be 3, river would be 2 and beer would be 2. So now how it happens? So here this input is first divided into key value pair. We can consider this is a key value pair concept by which the data is divided. If you have any questions on key value pair concept, please ask me in comment box. I will answer. So this is one of the key value pair representation in Hadoop. So this key value pair representation is called the splitting. It means the data is divided like this way. If you see I can consider there are 3 rows. So here 3 key value pair is considered. First one is K1V1, second one K2V2, third one K3V3. Then what happens? It is going to the mapping. It means it is mapped how many deer is there, how many river, car and beer is there. So here this mapping is happened. So in from the first key value pair, it is getting 1 deer, 1 beer and 1 river. In second, that also 1. In third, also 1. So it means that in from every key value pair, it is mapped how many words are there. Now the next step is shuffling. So in shuffling phase, what happens? In shuffling phase, it is checking how many deers are present in entire 3 phases. If you see here, it does the entire shuffle and see deer is how many times. So here beer is there 1, 1. If you in shuffle, it means it beer and here also beer is there. So this 2 comes into first key comma list value. So in this shuffling phase, it is basically checking how many words are there in all key value pairs. So after shuffling, it is going to reducer phase. So in reducer phase, from this shuffling, we can get definitely that beer is 2, car is 3, deer is 2 and river is 2. So in final stage, this is a step where we will collect all the data which we will get from reducing level. So from this reducing level, we will get, this is the key value pair. We can consider the list as a K3V3. So here it is collecting all those reducer components and then it gives the final result as an output. That is beer, cut, tier 3. So like this way, the data is entirely processing into Hadoop system. If you have any doubt in any of this process, in any of the step, please ask me in comment box. I will definitely reply. Now coming to the last Hadoop component, that is Yarn. The full form of Yarn is yet another resource navigator, which is the management layer of Hadoop. This is the resource managing component of Hadoop. There are background processes which are running on each node. Basically, node manager on the slave machine and resource manager on the master node. They are communicating with each other for the allocation of resources. The resource manager is the counterpart of the earn layer which manages resource among all the applications and passes the request to the node manager. The node manager monitors the resource utilization like memory, CPU and disk of the machine and conveys the same to the resource manager. It is installed on every node and is responsible for executing the task on the data node. Now I'll be explaining every component of Earn. First, coming to resource manager. On receiving the processing request from client, it passes parts of request to corresponding node manager accordingly, where the actual processing takes place. It decides the allocation of available resources. It has two major components, that is scheduler and application manager. So mainly scheduler is responsible for allocating resources to the various running application, and application manager is responsible for accepting job submission and also provide services for restarting the application master container on failure. Now coming to the second component, that is node manager. So node manager registers with resource manager and sends heartbeats with the health or status of the node. Its primary goal is to manage application container assigned it to the resource manager. It keeps up to date with resource manager. It monitors resource uses like memory CPU of individual container. It performs log management also. It also kills the container as directed by resource manager. Now coming to the third component of Apache Hadoop Yarn, that is application master. Its task is to negotiate resource from the resource manager and work with the node manager to execute and monitor the component task. It is mainly responsible for negotiating appropriate resource container from the resource manager. It tracks their status and monitors the progress. Once application master started, it periodically sends heartbeat to the resource manager to affirm its health and to update the record of its resource demands. Now coming to the fourth component, that is container. It is a collection of physical resources such as RAM, CPU cores and disk on a single node. It grants rights to the application to use a specific amount of resources like memory, CPU, etc. on a specific host. Now, one point to remember is HDFS is mainly responsible for storage. So, HDFS gives the input to MapReduce to do the task. And then after processing the data by MapReduce, it gives the instruction, gives output to HDFS. So mainly from HDFS to MapReduce, it works as an input, and from MapReduce to HDFS, it works as an output. And another point to remember is there a standby name node which is present in Hadoop 2 version. It is always available in Hadoop 2 because once the secondary name node is down, then standby name node acts as a secondary name node. But it cannot replace the name node, actual name node properly. So that is one of the thing. And it means that standby name node somehow works on name node but not exactly works as a name node. So this is one of the points which needs to be remembered. And another last thing is default size. The main default port size of name node is this 54310 and data node is 54311. So these are the some points which I mentioned so that it needs to be remembered because this is a basic thing. What is the default size? So that's why I have mentioned this one. Now we'll go through different interview questions which can be asked in different company. I won't explain those things in details. If you have any questions or any of those questions or answer, you can ask me. I will definitely answer. So you can go through interview questions, and you can think and you can check it out whether you have any doubt or not. If you have any doubt, so definitely I will come there. So thank you so much. That's all from Hadoop version. Whatever every Hadoop related thing, data processing, storage, and all related in details has been explained here. So if you have anything, any questions, you can comment. So I will definitely surely answer for that. So thank you so much. Have a great day.